Good evening, students. Now, in chemical equilibrium, I want to explain about the problems based on the degree of dissociation. If you take 2 hydrogen iodide, 2 moles of hydrogen iodide, dissociate will give hydrogen plus iodine. The degree of dissociation of HI is alpha. Calculate the expression for equilibrium constant case if the reaction. We know representation, writing of the equilibrium constant. You write it, hydrogen concentration to the power of the coefficient, and also iodine concentration to the power of coefficient by HI whole square. We know this one. Initially we taken as this as a 1 mole. If you, for example, whatever the coefficient is there, first you have to consider 1 mole. Initially, after equilibrium, what will happen? 1 minus alpha will be dissociated, then they will form here 2 moles dissociated, they will form 1 mole of hydrogen, and also 2 moles of HI dissociate to form 1 mole of iodine, means half of this one. That's why we write is alpha by 2 and alpha by 2. The concentration is divided with volume. Then we write the Kc. Kc is equal to concentration to the of hydrogen to the power of 1 by this one. Substitute their values to here, then we get the alpha square by 4 into 1 minus alpha square we get. Next, this is expressed in Kc. If you want to, next problem, N2O4 dissociated to give 2 nitrogen dioxide. For this alpha is 0.25 at 1 atmosphere pressure. The rate of Kp is, here we have to find out the Kp is close to the given 4 options. Kp we know how to write, the partial pressure of NO2 whole square by partial pressure of N2O4 to the power of 1. This is atmosphere square, atmosphere cancel 1. The total pressure, if you take A and B, two different molecules, number of moles of A, number of moles of B. If you want to find out the partial pressure of A is equal to number of moles of A by total moles into total pressure, same partial pressure of B, this you know. Like that 1 mole is dissociated from 0, 1 minus alpha is 2 alpha. This is the initially at equilibrium. Then we write the Kp. Kp is equal to partial pressure of NO2 whole square by partial pressure of N2O4 to the power of 1. Partial pressure of NO2. What is NO2? Here NO2. This is 2 alpha by total moles is 1 plus alpha into pre. This is whole square by partial pressure of N2O4 is 1 minus alpha by 1 plus alpha. This is 1 minus initial moles n minus alpha by total moles 1 plus alpha into total pressure. Then after that we get this expression. Here we given as a pressure is 0.25. We substitute the alpha values at total pressure is 1 atmosphere. Then we get the answer is 0.